We have 5 interesting presentations, and the first presenter is Magnus Frodigh from Ericsson, and Magnus serves there as a CTO. So please, Magnus.
Yeah, thank you very much. And thanks for inviting me here to this first 6G Summit. And let me share a little bit our thoughts towards a connected, intelligent future. I think the messages here will really be the connectivity is, of course, a central piece. Evenly important is, of course, the edge compute capability, and on top of that, the artificial intelligence. And all of these are extremely strong forces, right? And together, we believe that this will take us towards this connected, intelligent future. But let's take it a little bit in steps. So first, I think I would really like to point out that 2019 is really the year of the commercial launch of 5G, right? So we have a build-out now of networks in all different parts of the world. We are seeing that we have equipment now for the low band, for the mid band, for the high bands. There is interoperability tests according to the sort of 5G standard with all the major chip vendors, and we will have smartphones during the year, right, supporting the technology. We have key operators, and of course, some of the early ones were out in this fixed wireless access area, and that could, of course, be a new application area to be addressed. But of course, the first wave is really now around the enhanced mobile broadband, of course. One thing that we included in the 5G requirements when we started 2012 something, that was, of course, the massive IoT. And here we have one good example of something which has come earlier, right? Because it was a need from the market in order to solve this problem, and we were able to do this on top of the LTE networks. And here it goes, of course, even more faster, because here it is a software upgrade, right, on the existing LTE networks. It's a little bit of fragmentation here. Some countries are going from the narrowband IoT mode, some are going for the LTM, but I think we are now seeing an increase. Countries are going to both, and I guess this map will go purple gradually, and these two technologies will be offered in all markets, would be my estimate. Then this leads into something which is more taking advantage of the actual new 5G capabilities of providing the low latency, ultra reliable communications. And here we had a demonstration just to show how far we can get with this technology. So here we have showing how you can have multiple robots. In this case, there are 18 robot servers working together in a collaborative way, where we have moved the robot control into the edge cloud, connected over a 5G link in order to have a low latency. And we showed this in Barcelona this year, and we also teach this hexapod, as we call it, to dance. So just showing an example of what you can do with sort of low latency connectivity, edge compute, and then putting AI on top of that. So taking a look a little bit now, looking into the future here. And I think we are really seeing an extremely strong evolution of the 5G technology, as the previous speaker here today and yesterday were pointing out. So I think we will see, of course, 5G evolving. It will address all of these new use cases that we are thinking on. We are in release 16 adding features in order to do that. Of course, we will go for even higher frequencies. These are also sort of discussed in the 5G evolution tracks, right? We are, of course, going for the full network with all of that, and we will have all the implementation pieces. But I think the important thing here is not only the 5G evolution, it's really the combination here. So what we are really interested in is the combination of the connectivity and the edge compute. I think we would like to see a mutually aware systems that you are allocating the compute resources you need at the right place, depending on exactly what kind of connectivity you have available and what you would need for that application in that slice. So I think this interaction between the compute and the connectivity will be a key feature going forward. When you have that, you can realize that already that network that we have today is sort of very complicated to manage, and we need to set up and take down these different slices. We, of course, need sort of to use the machine learning automation for our own network, obviously. But on top of this, distributed compute and the connectivity, of course, we will apply a machine learning on top of that. Then something we perhaps not addressed so much so far here, that is that we have always in our industry have a strong focus on security, right? So we have encrypted links, we have authentication of devices and base stations and so on. But to really address these new cases, we need to lift this to a new level. So we need to take a more of an end-to-end approach, and we really need to make sure that the applications on top of the network and the compute are sort of assured. And in order to do that, we need to really integrate the security thinking in order to reach a trustworthiness level of these networks in order to be able to address these new opportunities. So a few examples here, shortly, on what we believe would be the new technology things relevant in a 5G evolution and beyond time frame. I think we are really seeing the 5G system based on the fully utilized central massive MIMO schemes. Right? We have a lot of antennas concentrated to one point, and we are able to then cover an area with beams and coverage over the surface. But of course, you can have a much more evenly performance of your network if you are able to distribute the antennas over the surface that you would like to cover. And then you would like to distribute the antennas, and you would also like to distribute the beamforming capability, so you are able to do sort of a local beamforming around each of these points where you have antennas. And then this is great, right? But it's a lot of practical problems in this. And here the concept of the radio stripes comes in. Because in order to be able to provide the antennas, you would like to provide the compute for the beamforming piece. You would like to have the backhaul to these, and also the power supply for this. We can integrate this into sort of one structure. And that is really what we now on the concept level call the radio stripes. And this is an example of how you could provide coverage then in such an area. You can sort of have these radio stripes around this area, and you can have sort of an ubiquitous, from all different angles, radio coverage. And here is a sort of a public space, but I think you will see this in other sort of airports, stations, stadiums. You will see this in factories. Perhaps you would like to deploy this in your homes or something, right? So this is a way to practically deploy a distributed massive MIMO system and still be able to pull that to connect that to some baseband unit in a realistic way. So this is one very interesting field of research I think we definitely need to do more work in. Another thing that I talked about is, of course, the build out of the edge. And there is one very natural driving force of this, of course, and that is the latency. How far can you get on a certain number of milliseconds? So we see the big sort of public service providers, and we have an example approximately where they have their mega data centers today. And they are, of course, building out, and they are addressing what they call the edge, right? So they are moving from the few big data centers to a little bit more regional data centers. And then you get into sort of the operator's domain, where they have the presence in different places. And they have then the possibility to build even denser edge cloud. And then, of course, you can think about having part of the edge cloud all the way out in the device. So why don't we put everything in the device then? Because that will clearly be the best, right? And the obvious reason for that is, of course, that there's another force pushing it out of the device, and that's, of course, the amount of compute that you would like to make is sort of increasing exponentially. But the battery capabilities of the device is limited, right? And that will, of course, improve slightly, but the gap between what you would like to do and what you could afford to do with a reasonable battery lifetime, I think that will just increase. So there's a strong push to offload compute from the device into the network. So I think the importance of the edge will increase. Another, of course, reasoning for why that is, of course, it's a huge amount of data. And you would like to handle the data early, close to the source as well, right? So there's, of course, a cost of moving data into a central point. But there is also, of course, of how to push the compute more decentralized. So this is a balance that we need to figure out. What is sort of the most financial viable alternative where we will see this trend? And I think we will see all over the place depending on the application and the need of the application. And here are some examples. If you have 50 milliseconds round trip over fiber, you can do almost all Europe or half of the globe. 20 milliseconds is a little bit almost all Europe if you put it in Stockholm, the center. Then 10 milliseconds is northern part, 5 milliseconds is really sort of getting more regional. And then, of course, you need a little bit of time for the actual compute as well. So you can see that there is a need to push out the edge in order to have these response times. When we have that edge, we will, of course, like to put the artificial intelligence on top of that. And then, given that we have the connectivity, the compute, of course, we should do the AI then in real time as well. I think this is an interesting field to understand how you can work on the real-time data out of these networks on the edge of the network. And then, obviously, it will be a distributed. So we are into these federated learning schemes that you can learn something in one area and then you can sort of transfer that learning to another area and then you can reuse that and learn more over here and then you can use that somewhere else and so on. So the distributed capabilities of AI is, of course, a key thing. And then back a little bit to this trustworthiness. I think we need to make sure that the AI now is sort of learning and behaving something which is sort of transparent, it can be predicted, and it could be sort of guaranteed to be safe and trusted, right? So I think these fields are also coming up in this context. So that was sort of 3 examples of areas where I think is extremely valuable to do research and then trying to put it together a little bit in a big picture here. I talked about different forces, so let's go a little bit into this. And my point is really that it's a combination of these forces that will drive the evolution now, and it will go fast, I think. So, being from Ericsson, I guess we start with the 5G and that fundamental availability of the connectivity, right? On top of that, we will see a build-out of this mobile connectivity using this technology. So we will have an extremely dense and strong connectivity capability. Then we have the IoT, where we will have devices, intelligent, embedded intelligence. They are able to communicate and interact with each other. We see the cloud and the edge compute trend. We all think about the AI and automation capabilities evolving extremely quickly. It's also so that there will be new ways of interacting with these systems. So you will see haptics and AR, VR, and different things also sort of evolving very quickly. And all of this turning into robotics. We will see hardware, real sort of physical robots, but a lot of software robots, which is then close to automation. And then I think we really need to make sure that the trustworthiness 4 series is enhanced a little bit, I think. Otherwise, a lot of these things will fail due to that. So what will this mean then? And I think we already in the 2025-ish time frame, I think we will have seen big changes. Internet, it's Internet of Information, what Internet of Things. I think we perhaps are into some sort of Internet of Senses. You are able to store your experience, and you can replay that and so on. It's interesting. Cyber-physical systems, I think in a lot of different environments we will have a fully programmable world, so we will be able to control everything, right, with software. We will have built out the networks, and we will have the edge available. And the networks will be, we have gone indoor, we have very dense networks with new capabilities. And of course, with all of these new use cases, there will be a lot of new devices being connected besides just the smartphones. And then let's stretch this even further then and go to 2030, see what that could be. So the edge and the connectivity had evolved now to a sort of universal compute fabric, swarm intelligence. Perhaps we are in the Internet of Thoughts, brain waves, brain interfaces, light fields. There's a lot of development going on in this field. Let's see how they are integrated into our systems. I think we see new computing paradigms, metamaterials. It will definitely be significant enhancements in the availability of different quantum compute capabilities. And the good news, I think, is that this technology, applying that to all of these different sectors, would have made significant impact on the greenhouse gas reductions in this time frame. So in that, I'm really optimistic, and we will, of course, we talked about it earlier here. This is, of course, a responsibility for all of us to make sure that the technology and the potential we have here is coming fully in use in that area as well, of course. So, final slide. 5G is here and now, and it will be expanding rapidly. We will continue to evolve this, and I think it's very timely now to look at new possibilities, do new research, and I would estimate that a lot of the ideas that academia have now and start to work on, these will be all absorbed by this 5G evolution, because the evolution on the 5G and the evolution here will be rapid. But that's not a problem to me. That's just excellent work, and we will all benefit, and we can deploy and use. Then, of course, there are things beyond. It's a little bit difficult to pinpoint what exactly is beyond and would really make this shift into next generation. So, thanks a lot.
Thank you, Magnus. Do you have questions or comments to Magnus? Maybe then I have to ask you something. You mentioned several, let's say, quite far-reaching things that we could look at when thinking about 2030s. But if you were in the position to pick one which would require, in your opinion, biggest efforts, what would that be?
Yeah, I think it's very difficult to down-select further than I did now. If you're interested in these human interaction aspects, I think, of course, you could start to look into haptics, AR, VRs, into senses, into brain waves or whatever it is. I think that would obviously take a long time, and I'd expect that we will see an evolution of that for more than 10 years. So that would be one selection. If you are more interested in the machine types, of course, we can stretch it into the extreme capability of a future factory where you have thousands of robots working together, and that will be an extremely interesting control problem, right? So I think there are so many opportunities.
Good time for us researchers, I would say.
Yes, it is.
So
Really.
questions, please. We have time for a couple of questions if you have any.
Maybe I can just make my voice. Can you share your more idea on trustworthy network? What kind of research do you do for making network trustworthy?
Yeah, I think the trustworthiness is an interesting topic. And yeah, okay, yeah, please, yeah. Take two questions in one.
What do you have in mind in that area? End-to-end, do you have any more particular ideas?
I think it's natural to think to start about the robustness, so you can have multiple diversity paths, right? And you should make sure that you have time for retransmissions within your time budget. So it starts with some robustness, and then you can get into reliability, how you can sustain attacks, and also how you can sort of monitor and have a firm view on the current level of robustness or resilience in the network. So I think that's one field. Then a little bit end-to-end, I think we need to, it's not enough to secure the network, you need to go up in the protocol stacks, and you need to be active also on securing the actual applications and make sure that these are end-to-end reliable. Because if you have a lot of application that you can't trust, then these could sort of influence the network in an unwanted way. So I think there is sort of a lot of technical things. Then I guess you can also get into assurance, how you can guarantee a certain level of assurance, and there's a lot of regulation in this as well, which could also be studied, I think.
Okay, thank you, Magnus. Let's give him a big hand again.